Yes, come on in. Hope everyone had a great weekend. We had nice weather this weekend, relatively speaking, compared to tomorrow when it's supposed to be like nasty, rainy, and possibly severe storms and could turn into flakes by the evening. I don't know. It's weird, weird weather. But anyway, it's March. It's March, so we'll take it. So yeah, hope you had a great weekend. I had a very busy weekend. We wanted to go to a movie, we just couldn't find the time. My sister, I have a sister that lives. I have three sisters, and they all used to live in Oklahoma. But I have a sister that lives in Louisiana that moved from Oklahoma, and they downsized. They had a huge house, great big huge house. Now they have a nice little normal sized house. Her husband's a family doctor. He's been a physician for 40 years. So they had this like 6,000, over 6,000 square foot home. Now they're in like 2,500 square foot home. So she has a lot of furniture that would not fit in her new home that they were just going to like give away to charity or something. So we found out about that. And my wife said, how about your dining room table? Are you taking that with you? She said, no, it will not fit in my new house. So I said, do you guys want it? My wife said, yes, yes. So she really wanted the chairs and the table. So we rented a U-Haul trailer Friday night. Saturday, we drove to my sister's old house in Oklahoma, loaded up this table and all the chairs that go with it, and got home about midnight Saturday night. This table is 12 feet long. It's huge, 12 chairs around it. And it was really something for just me and my wife to load it because that was not easy, but it is. See, it's one of those special tables. It's a replica of the Vanderbilts. You know, the famous Vanderbilts that are like uber money for a long time. They own the Biltmore Mansion in North Carolina, and this is a replica of the dining room table that's in the Biltmore Mansion. So, oh, Lindy's been there. So I haven't been there yet. I'll probably have to go now that we have a replica of their table. But it's not as big as the table they have at the Biltmore because it's. I looked it up. I said I want to see what the table looks like at the Biltmore, and so I looked it up, and this is the picture I found of the table at the Bilt, and that's like crazy big. What you got, Lindy?
Just like a really like crazy comparison. The pool that they had, the pool itself and the layout of it was like larger than my house.
Oh my
Like
gosh!
most houses here.
Yeah, I mean, you know, this dining room is huge here. You see this picture. So our chairs kind of look like that too. There, it does resemble those. A little bit different. The top of them is a little different, and our table is really big. Like I say, our table is 12 feet long. This one's a lot longer. This has like 26 chairs around it, whereas only has 12. But it's a replica of this, so it does have that same style and looks a lot like it. But yeah, the Biltmore. It's a museum now. I guess you can go in the Biltmore. But that's crazy. Crazy place here. But so we own a table now that's a replica of that. On the bottom of it, it says Biltmore. It's stamped on the bottom of the table. So that's what we did this weekend. We went and picked up a free table from my sister who didn't want it anymore because it wouldn't fit in her house. 12-foot table. That's not a lot of people can fit a 12-foot table, but that huge room we're building, we can fit this table. So we have that. Anyway, so that was our weekend. It was kind of exhausting driving Oklahoma and back. But before we get started, I do want to talk about this class because yeah, you guys are. I guess I can use the word amazing because right now I'm amazed. This is my largest class. There's 35 of you here. Well, right now there's 30 of you here, but there's 35 in the class. And this is an Algebra 2 class. I have Algebra 2, Algebra 3, programming, cybersecurity. And historically, every year, Algebra 2 is my classes that struggle the most. They get behind. They don't turn in tests. They have low grades. Not everybody, of course. I mean, most of you guys do great. Most of you do great. But there's always, if anyone's going to struggle, it's going to be some of my Algebra 2 students. So I always have. And I was just looking because I updated all the grades on Friday. I haven't updated what you turned in this weekend, but that's just what you turned in helps. As of the grades right now, when I look in Buzz, no one is failing this class. 35 students, Algebra 2, third period, nobody's failing. Now, there's some of you that's under 70, so you're still supposed to be here later in the week. This is an A-Day Friday. But you're in the 60s. You're not like in the 30s. You're not failing the class. And so I'm amazed because I don't think I've ever had an Algebra 2 class where no one is failing in March. I'm kind of stunned. I don't really know what to do with it, especially since this is the largest Algebra 2 class I've ever had, and still no one is failing as of this moment here in March. So bravo, bravo. Got to say, you guys are doing great. Now, some of you can do better because just because you're passing doesn't mean you're really where you want to be or where you need to be. So we'll get there, but we're not digging out of a big hole. And here it is, 3 weeks from spring break. So kudos, great job. Hope that's an encouragement to you, because it's an encouragement to me that you guys are handling this and doing well with it. So marvelous. So with that said, let's jump into what this looks like today for Algebra 2. Okay, Algebra 2. Let's look at our grade screen. This is always the best place to chart. If you're not going to the grade screen at least once a week, you should be, just to make sure everything is submitted. You've got a grade for everything. How we doing? Okay. All the way to March 2nd. That was this past Sunday, yesterday. So everything should be turned in above that. You should have no missing assignments. And most of you don't. Most of you do not have any missing assignments. So that is fabulous, fabulous. All right. Let's go down and look. March 9th is this Sunday. So we have the multiply matrices by scalars and a matrix equation scalar multiplication assignment. And Anthony's having trouble with the scalar multiplication assignment. We'll look at it. I don't know how that's working. So this is in the week 25 folder, but remember I kind of separated it, pushed it back a week. So we're just doing the multiply matrices by scalars folder. So let's take a look at that. So we've already done the adding, subtracting matrices, but this one may be doing the same thing. Now remember last week, sometimes on the second assignment, the answer would be like a 2x3 grid, and it would give you a 3x3 grid and wouldn't count it right. So if you're having that problem, screenshot the screen, just do a screenshot to show me, oh, look, it's giving me too many spaces, and just turn that in and I'll give you full credit. So, all right, we're going to look at the video and the lesson and then go through the 2 assignments here. It's slow loading as usual. It'll get there. Come on. There we go. All right. Scalar multiplication. Concat. We'll see how long this is. 2 minutes. That's not very long. 2 minutes, 18 seconds. Let me open that up. Let's go.
Now that we know what a matrix is, let's see if we can start to define some operations on matrices. So let's say I have the 2x3 matrix, so 2 rows and 3 columns, and the entries are 7, 5, -10, 3, 8, and 0. And I want to define what happens when I multiply 3 times this whole thing. So first of all, let's get a little terminology out of the way. The number 3 in just the everyday world, if you weren't dealing with matrices or vectors, and if you don't know what vectors are, don't worry about them just now, you would just call that a number, or you would call this a real number. It's just a regular number sitting out there. But now in the world where we have these new structured things, these matrices, these arrays of numbers, we will refer to these just plain old real numbers that aren't part of some type of an array here. We call these scalars. We call this a scalar. So essentially what we're defining here, we don't know, I haven't said what this is actually going to turn out to be, but whatever this turns out to be will be a product of scalar multiplication, or we're multiplying a scalar times a matrix. And so how would you define this? What do you think this should be? 3 times this stuff right over here. Well, the world could have defined scalar multiplication however it saw fit, but one way that we find perhaps most obvious and most useful is to multiply this scalar quantity times each of the entries. So this is going to be equal to 3 times 7 in the top left, 3 times 5, 3 times -10, 3 times 3, 3 times 8, and 3 times 0, which will give us, it didn't change the dimensions of the matrix. It didn't change, I guess you could say, the structure of the matrix. It just multiplied each of the entries times 3. So the top left entry is now going to be 21. The middle entry, or the entry in the middle row top column is going to be 15, negative 30, 9, 24, and 0. So when you multiply a matrix times a scalar, you just multiply each of those entries times that scalar quantity.
All right, pretty straightforward, pretty simple. Scalar multiplication. All right, so multiplying matrices by scalars is just simply taking the number and multiplying it times every element in the matrix. Let's look at the lesson that goes with that. Multiplying matrices by scalars lesson. Remember, anytime you're at Khan Academy, make sure your name's up in the corner. Make sure you're logged in so it keeps track of everything for you. See, it shows that I've done some of this before with 100%. So if you forget to screenshot it, you can just screenshot that and show that I did multiplying matrices by scalars and got 100% on it. So, all right, what you should be familiar with. It always reviews what a matrix is. This is 2 rows, 3 columns. This is a 2 by 3 matrix. It always shows you that. So we're going to learn how to multiply matrices by real numbers, scalars, and scalar multiplication. So any real number out here, we're going to call a scalar. Like, you know, there's 2 times 2 is a scalar. This is scalar multiplication. So it says, okay, given that we have this matrix A, and it's 10, 6, 4, and 3, let's find 2A. So 2A is just taking 2 times A, and this is matrix A. So if it's 10, 6, 4, 3, and we have this scalar 2 out front, 2 times 10, 2 times 6, 2 times 4, 2 times 3. So our matrix becomes 20, 12, 8, and 6. We've scaled it up by 2, by a factor of 2. That's why we call that a scalar. Scales it up by a factor of 2. All right, so here's check our understanding. I'll open up the chat here and make sure I can see that. Give me the answer of what is negative 3b using this matrix B we have here at the top of the screen. What is the top row going to be? It was originally -4, -2. And we're trying to find negative 3b. So -3 times -4. You guys got this? 12. -3 times -2, 6. All right, what's our bottom row going to be? -21. I'm seeing several -21s coming up. -3 times 1, that's the easy one right there. So let's check. Absolutely. All we simply have to do is just take -3 and multiply it by each entry. All right, here's problem number 2. A little trickier because it's fractions, but we can handle fractions. We're in high school now. Given C is -42, 27, and -3, find 1/3 C. 1/3 is a very easy fraction to use because you can either multiply by 1/3 or divide by 3. That's the same thing. Multiplying by 1/3 or dividing by 3. So what are the 3 numbers that we're going to use for this matrix of 1/3 C? Starting with -42, +27, -3. All right, Daniel's on top of it. 1/3. Don't let the 1/3 intimidate you, folks. It's just dividing by 3 when you multiply by 1/3. Because you have 1/3 as much as what you started with. So -42 divided by 3, -14. Or -42 divided by 1 times multiplied by 1/3. It's -14. 27 times 1/3. What's 1/3 of 27? 9. What's 1/3 of -3? -1 is 1/3 of -3. There's our check. And that's it. See how quick and short this assignment and this lesson was here? All right, let's go back. So I really should have put this with next week. I should have combined them. I didn't. I won't change it now. But I should have combined it with week 26. See, next week we have 3 lessons and our final quiz. Then we'll be done with matrices after next week. 3 lessons and our quiz. But I'm taking it easy, giving it easy weeks, and making sure. And it's been good to keep it easy weeks because you guys are catching up and no one's failing now. So multiply matrices by scalars assignment. Let's look at the first assignment. Remember, after you do this, you go down here, and this is where you paste your screenshot. And if you forget to get a screenshot, if you're logged in, it'll already have a score for you, and you don't have to redo it. You have to be logged in first. Multiply matrices by scalars. I've done this before with 100%. I could just screenshot that. Oh, and actually, I'm on question number 2 now. It says here, does it? Now, let me go where I can start over. I'll skip. Next question, skip. I want to get back to where I got all 4 questions. Okay, show summary. All right, 1 out of 4. All right. Wait, I didn't want to do that. I want to go backwards. All right, multiply matrices by scalars. Let's go. Find the product. 3 times 4, -2, -1, 4. Oh, it says you might need a calculator for this. They'll provide a calculator if you need one. You need to know what 3 times 4 is? There's a calculator. But surely you know 3 times 4. I wouldn't expect you to need a calculator for everything. -2, let's see. 3 times, how do they do the negatives on here? -2. Yep, -6. I just hit minus before I hit the 2. 3 times -1. Oh. And 3 times 4. So 12, -6, -3, 12. Check. Next question. All right, these look good. I want you to put this in the chat. X and Y, because some of you get confused when we use X and Y in the matrix. And so find the values of X and Y in the following scalar multiplication. We got 1/5 times this matrix equals this matrix. So you just have to look and see where is X and where is Y. X is right here. And it's saying 1/5 times X equals 6. So what is X? Put that in the chat. We'll wait till I get a few of you in the chat there because not many of you are participating at this point. Abigail's got an answer. Thank you, Abigail. Seth, all right. Megan's there, Soraya. All right, we think it's 30. 1/5 times 30 is 6. We're going to put that down. Now, what about Y? 1/5 times Y is -3. 1/5 times Y equals -3. And if you wasn't sure how to do this, you could always check the other one. 1/5 times 20 was 4. 1/5 times 20 equals 4. 1/5 times 0 is 0. But what is 1/5 times Y equal -3? So Y is, Luke says is -15. We'll see if anybody else thinks that. 1/5 times -15 equals -3. Again, you can always use that calculator if you need to, if you try to figure it out. If I do 1/5, let me just do it as a parentheses, 1/5 times, and we think it's -15, so I'll put -15. Let's see what 1/5 times -15 equals. Hey, -3, that's what we wanted. Check. Nice work. Nice work. All right, let's do the next one. Find the product. Okay, so this we just, what's the answer? -5 is our scalar. our matrix is 1, 0, negative 2, negative 1. Well, the top row is pretty easy, right? Negative 5 times 1 is negative 5. Negative 5 times 0 is 0. But what's our second row going to be? Little trickier just because you got more negatives. But we know a negative times a negative is a positive. So, yeah, the ladies, they're on it here. Good job, Mary, Ava. Negative 5 times negative 2 is 10. Negative 5 times negative 1 is 5. So we'll end up with one negative in the answer here. And good work. Next question. Here's another x and y, and they're in different places. The x is over on the left side, and the y is on the right side of the equal sign. So 1/3 times x, negative 1/3. That's where we make little mistakes. If we don't pay attention, there's a negative there. Negative 1/3 times x equals 2. Oh, that's a good one. What do you got? Negative 1/3 times x equals 2. Negative 6. Ava says x is negative 6. Some of you aren't sure. You can always use that calculator. If you multiply two numbers together and they equal this, you can always figure out what the other number is by going backwards and dividing, which is the opposite, right? 2 divided by negative 1/3, parentheses, negative 1 divided by 3. See, 2 divided by negative 1/3, negative 6. So negative 6 times negative 1/3 times parentheses, negative 1/3. Negative 6 times negative 1/3 is 2. So yeah, negative 6 is correct. How about 1/3 times negative 9? It equals y. Abigail's on that. Ava's on it. Yeah, 1/3 times negative 9. Negative times a negative, we know it's going to be positive. And 1/3 of 9, 1/3 times 9 is 3. There we go. Show the summary. This is where I want my screenshot. So let me take a screenshot of this. Marvelous. So I go back here, scroll down to the bottom, paste. There's my screenshot. Submit my work. Some of you may, I think on the Chromebooks, you may have to attach the file of your screenshot. It just works differently. All right, let's go back there. Here's our other assignment, matrix equation, scalar multiplication. Now, Anthony said this was doing like the one last week. It was giving some trouble, so let's see. If this gives you too many blanks and won't let you go on, won't count it right, screenshot the page that's doing that and turn that in, and that's good. That's enough. All right. Let me close this one down. See, last time I made 50% on this. I want to do this again anyway. Scalar multiplication. Let's go. Oh, here we go, right off the bat. 1/7 times x minus this equals this. This has a 3 by 3 matrix. This is not going to be a 3 by 3. This is a 2 by 2. If we're going to subtract matrices, they have to be the same size. But let's go ahead and work this. But I'm going to end up just having to screenshot this page because it's not going to count it right. So look at what we have to do here. 1/7 x. And just to show you guys, and it may work for some of you guys, how would I do this? I'm going to show you if you were totally lost trying to do this. I'm going to write this. I'm going to write this on paper because I want to show you. If I have this matrix, and I need to know what x is. X is, some 2 by 2, some 2 by 2 matrix. That's what x is. We've got to figure out what it is. And so there's should be 4 answers for that. If we take them one at a time, 1/7 x minus, let's do the first one, 1 equals 3. You can simply make them an algebra problem and work it this way. If 1/7 x minus 1 equals 3, get x by itself, add 1 to both sides. 1/7 x equals 4. We get rid of the fraction by multiplying by 7. 7 times the 7th is just 1. 4 times 7. So x equals 28. That gives us our first answer, 28. So 1/7 times 28 would be 4. Minus 1 would equal 3. So just write it out. So let's go back here and put 28. That one's 28. Then our next one, 1/7 x minus 2 equals -2. So add 2 to both sides. 1/7 x equals 0. Well, that just means x equals 0. Because you multiply 0 times 7, that one's 0. So our second answer, 0. Now there is no third one because we don't have a third column. This is where it's messing up and not doing this correctly. But let's go ahead and calculate these for our own purpose right here. 1/7 x minus 7 equals -5. Add 7. 1/7 x equals -5 plus 7 is 2. Multiply everything by 7. 7 times the 7th is just 1. So I got 1x equals 14. Great. Put in 14. And the last one, 1/7 x minus -1 equals 4. Minus -1 means this is 1/7 x plus 1 equals 4, because minus a negative. So subtract 1 from each side. 1/7 x equals 4 minus 1. Multiply it by 7 on both sides. X equals 21. So yeah, if it's confusing you do where they're putting this and the x and all of that, just do them one by one as an algebra problem. X equals 21. All right, check. Says not quite. It's messing up because it says there should be something here. No, there shouldn't be anything there. Show a step. See, here's how they're working it. Get another hint. Get another hint. And here's their answer, 28, 0, 14, 21. 28, 0, 14, 21. We have the exact same answer. But, see, there it is, 28, 0, 14, 21. But it's not letting us go because it messed up. It gave us a 3 by 3. Not quite. Give it another try. See, it won't let us even skip to the next problem. It's stuck. It's stuck. So what I do then, at this point, I just go back and take a screenshot. Look, I did it. I've got an answer. It's not letting me go on. It's messing up. And I come back here, paste my screenshot just to show, hey, Mr. Brock, it's giving me extra spaces. Submit that work, and I'll give you 100%. I'll say, okay, great job. You did it. That's fine. Draw on exercise. Oh, that's interesting. I can do that and go, that's messing up. All right. I can reload it and see if it's still going to do that every time. But yeah, if it's messing up like that, just give me a screenshot to show that it messed up for you, because it may not mess up every time. Sometimes I get problems that I can actually do. Oh, it's still in this same one. It won't let me go. Make sure you fill in all cells, it says. Oh, yeah, well, X, 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 X. Yeah, it's stuck. It won't let me go anywhere. But yeah, just do that and turn that in, and you're good to go. If it lets you do it, it may work. It may work properly for some of you if you go there sometimes, because sometimes it'll actually give me problems I can do. Like it said I had 50%. So last time it must have been 2 problems I could actually do. And then the others I can't. So I don't know why. This is the first year, and I've used Con for many years. The first year that's really messed up, and they haven't got that fixed. So I will keep sending them reports that it is not right, but get done what you can. The important thing is, do you understand? Are you getting the same answer they did? We got the same answer they did. It just won't count it correctly because it's putting too many spaces in our matrix. But that's okay. Next week, we're going to be wrapping up matrices. We're going to look at matrix addition and scalar multiplication, the properties of that. We're going to talk about zero matrices. Get a little tricky if you're not paying attention. And the properties, like I said, of the matrix addition and scalar multiplication. But the zero matrices, you got to pay attention because they'll phrase some questions in an odd way on a quiz that you're like, what? How's that work? And I don't want you to get confused by that. So we're taking matrices nice and slow. I always said that a lot of students raise their grade during the matrix lessons because they're short, they're pretty simple to understand, and you can go back and redo them until you get 100%. Like if I would have missed 1 or 2 on that first assignment, on the left side it says try again. I can just close the window and try again. And I didn't screenshot it because I didn't get 100. I'll wait and try it again. 4 questions, they go real quick. 100%. Now I'll screenshot and turn it in. So a lot of students really raise their grade during the matrices. And that's obviously the case this year because nobody is failing and we're into March. I'm very excited about that. But if you have any questions on this, please ask. I don't want you to be lost during the matrices. I don't want to lower your grade because it is pretty simplistic. I hope most of you are finding it pretty easy, saying, hey, Mr. Brugg, this is all right. It's pretty good stuff. So we'll spend one more week on matrices after this week, and then we'll start something else before spring break. We just got 3 weeks till spring break. So that's coming up real quick. But anyways, you've got time to get these matrix lessons and assignments done before your next class. So I will let you use the rest of this period for that to get your assignments done. I'll be here if you have questions or anything, but otherwise the rest of the period is yours. It is an A-Day Friday.